In this lesson, we're going to define mole and then learn how to use Avogadro's number in calculations. A mole is just a counting number, and you're already familiar with counting numbers even if you didn't call them that. If you have a pair of something, that means you have two of it. If you have a pair of moles, that means you have two moles. Pair means two, regardless of what you're counting. If you have a pair of anything, then it means you have two of that thing. If you have a dozen of something, that means you have 12. If you have 12 moles, you have a dozen moles. Just like a pair, the meaning is defined regardless of what you're counting. A dozen always means 12. When we use the term mole, it's the same thing. It's a counting number. It just so happens that that number is really large. 6.022 times 10 to the 23rd. If we're counting something and we have 6.022 times 10 to the 23rd of that thing, then we say we have a mole of it. I can't show you a picture here of a mole of moles, but if we covered the Earth in a layer of moles to about 50 miles deep, then we would have a mole of moles. To put that in perspective, 50 miles is about the distance from one side of Lexington to Louisville. We're going to be using this number a lot, 6.022 times 10 to the 23rd, regardless of what we're counting. In this case, we were talking about moles, the animal, but we can also talk about electrons or atoms or molecules. And if we have 6.022 times 10 to the 23rd of those, then we have a mole. If we have 1 mole of helium atoms, how many atoms do we have? We're talking about 1 mole, therefore A is the correct answer. We have 6.022 times 10 to the 23rd atoms. 1 mole of atoms contains 6.022 times 10 to the 23rd atoms, just as 1 dozen of something contains 12 of that thing. We do need to be careful with our abbreviations. Mole is generally abbreviated MOL, molecule MOLEC, and M is for meters. Pay attention to what unit you're looking at and make sure you're using the correct abbreviation. How do we use Avogadro's number when we're doing these calculations? The big way we use it is going between moles and molecules or moles and atoms. Avogadro's number, or 6.022 times 10 to the 23rd, is used as a conversion factor, also known as a relationship. It connects two different things. Just as we can say 1 dozen equals 12, we can say 1 mole equals 6.022 times 10 to the 23rd. Notice that the 6.022 times 10 to the 23rd always goes with the thing that we're actually counting, and the mole goes in the other spot in the fraction. However, we can invert that fraction depending on what we're starting with and what we're trying to get to. Just like we used units in dimensional analysis before, we're going to continue to use them in dealing with moles, molecules, grams, and atoms. We showed this as question marks here in this example, but no, we can put anything there. It doesn't matter what we put there. It's whatever we're counting. If I'm talking about a dozen people, a dozen books, a dozen pencils, a dozen donuts, a dozen still means 12 of each of those things. In the same way that if I'm talking about a mole of molecules, it means 6.022 times 10 to the 23rd molecules. If I'm talking about a mole of atoms, it means 6.022 times 10 to the 23rd atoms. It's just a way to count the number of something. Let's look at how we'll use this in a calculation. How many molecules are in 2.25 moles of H2O? We're going to use the same process as we did before with dimensional analysis. We know we want to end with the simple unit molecules, so we need to start with a simple unit. The only number we're given in this problem is 2.25 moles. So we'll start our problem there. We're starting with moles, therefore moles needs to go in the denominator of the next step so that those units can cancel out. We're trying to get from moles to molecules, and we know a relationship between those two numbers with Avogadro's number. 1 mole equals 6.022 times 10 to the 23rd molecules. We can use that relationship to get between moles and molecules. We put in our number, 6.022 times 10 to the 23rd molecules is equal to 1 mole. Now we can cancel out moles, and we're left with units of molecules. For my calculation, I can take 2.25 times 6.022 times 10 to the 23rd, and I get 1.35 times 10 to the 24th molecules of water. How many molecules are in 1.38 moles of CH4? Again, we're looking for a simple unit for our answer, so we're going to start with a simple unit. The only number we're given here is 1.38 moles, so we start with that. Set up our next step. We put moles on the bottom because we need those to cancel out. Molecules goes on top. Now I need to decide where I'm going to put Avogadro's number. Because 1 mole equals 6.022 times 10 to the 23rd molecules, it goes in the numerator. Now I can do the calculation of 1.38 times 6.022 times 10 to the 23rd and get 8.31 times 10 to the 23rd molecules. And A is our correct answer.